Okay, so let's just go a plus b squared a minus b and a plus b a squared minus b squared. So there are our three patterns that we worked on when we expanded our brackets. Now that we're factorising, we're looking for these patterns so that we can go back that way, because these are factorised, these are expanded. So we're looking for these patterns so we can go back to a factorised form. We factorise a lot, don't we? Okay. So let's start with something like x squared minus 9. Factorise that. Okay, so what we're thinking is difference. Well, we've got something squared minus something squared. So that's actually x squared minus 3 squared, isn't it? Difference of two squares. X plus 3. X minus 3, because that's our pattern. If you don't know your patterns, go back and do that expanding patterns exercise and do them all twice like I told you to. Okay. What happens when that thing's not a square? So is that a difference of two squares? Because 7's not a square number, is it? Well, actually, we can make it. It's a squared. What's root 7 squared? 7. So again, that is a difference of two squares. X plus root 7, x minus root 7. So don't let the fact that that's not a square number fool you. We're looking at that minus x squared minus a number. You're going to get that a plus b, a minus b. Similarly, you might think there's nowhere to go there because 3 and 5 are not square. So technically that's root 3 multiplied by x all squared minus root 5 squared. Something squared minus something squared. Root 3x minus root 5 plus root 5. So x squared and a minus is what you're looking for. 4x squared minus 12. And don't rush into it. Always look for the simplest first. 4 and 12, oh my gosh. 4 x squared minus 3. And then we're going to go 4, because this is a difference of two squares where that's root 3 squared. So it's going to be x minus root 3, x plus root 3. See what I mean? So always make sure you look for your easiest first and then follow up. Okay. So it might not be obvious straight away. Remember, we can factorise this. A is 1, so we would get the factors of 9, just like we did in the last video. But if you can see it, we can go x squared minus 2 times 3x, and 9 is actually 3 squared. So I'm going to use that box in completing the square, so get used to looking for this sort of pattern. So that's our a squared minus 2ab plus b squared, which factors, doesn't it? And the reason I put this box in, because that's the number that goes into our brackets that get squared. Clearly we're going to get our same answer if we do this 9 up here and factorise it out. But as soon as we can see that pattern, we are far better off. 2x squared plus 20x plus 50. Clearly everything's divisible by 2, so let's get rid of that 2. X squared plus 10x plus 25. We're thinking this 10 is 2 times 5, and that's 5 squared. So rather than doing a whole 25 and doing it that way, we can think of it as x squared plus 2 times 5x plus 5 squared. And that 5 is the thing that goes into our bracket. Remember, because that's a plus, that's a plus. You might think it's sort of a little bit weird that I don't go 1, 25, 5, 5, and I'm going to circle them because they add, and then that would get me to 2, x plus 5, x plus 5, which gets me to the same answer, but we will be looking for these patterns in different questions as we move through the years. So the sooner you get used to it, the better. Okay, that's it.